Welcome to the Daily Space Weather. We've got fascinating imagery. We're going to spend a lot of time on solar imagery today, more than usual here at the Smash News Network, Least Busted Name in News. We've got a very high likelihood of coronal mass ejections and large solar flares. Lots of stuff going on. Forecasts coming true about sunspot evolution and so on. So check it out. Here's some composite imagery from SDO. That's 24 hours in 304 plus 193 angstroms. And check out the prominence. Partially anchored to that sunspot 3112. Yes, 3112. It's exciting stuff. Exciting stuff indeed. So here's the sunspot evolution that we're talking about. We saw these sunspots in the southern hemisphere degrade, and these ones in the northern hemisphere grew. They've gone from alpha to beta class now. Again, very high likelihood of large flares as we see these sunspot groups. 3112 being the most impressive sunspot group of the entire solar cycle, setting here on the northwestern limb. That raises the likelihood of large flares to what we'd call very high. So again, we're going to blast through data today. We're going to blast through. We don't want the video to be too long. We just want to show you the most comprehensive space weather there is in the world, and the most detailed solar imagery you'll find any place on the internet. Thanks for tuning in, by the way, to the Smash News Network, Least Busted Name in News. Don't forget to press like and subscribe if you enjoy the content. Check our playlists for videos that aren't the Daily Space Weather. Some aesthetic stuff there, and SmashAmash.org presents the sun. Some stuff about cycling, driving, pro tips, terms defined, Diamond Anvil, too hard to smash, product reviews, even some recipes on the channel. Congratulations on realizing it exists. If you want to support the channel, since we make just a side of nothing putting the videos on YouTube, consider becoming a member of the Smash Team. At smashamash.com/Smash Team, we created our own website because, well, we needed superior capabilities to Patreon, although we still are on Patreon technically, thanks to everybody who's supported us over the past nearly 6 years of putting out the most detailed space weather videos you'll find any place. smashamash.com/Smash Team. Join at the gold or silver membership level for additional content, and if you'd like to support the channel, increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. You can find links to that on the homepage at smashamash.com, and welcome to the Neo Renaissance. Check out the merch shop as well. We'll talk about that here momentarily. The merch shop. If you click the link, you'll find our products in order of best selling. We've got a re-release to feature today. Once again, welcome to the Neo Renaissance. Another link you'll find on the homepage right here at smashamash.com is the link to ShoreMed. If you want to improve your health, we at the American Better Health Organization would like that too. That's our focus at the nonprofit organization. So check us out over there. You can find my personal link below the video in the description, as well as on our homepage at smashamash.com. Base membership includes things like doctors by phone, counselors by phone, virtual veterinarians, dental discounts, vision discounts, and lots more. The pharmacy discounts are spectacular. And those alone might make it more than worth joining at the base level. You can also add group insurance, only available to ShoreMed members. Again, find the links below the video. Today's featured product is Smasher Price, My First Pandemic. And of course, I'm wearing it today. So here you go. Here's your official plug, Smasher Price, My First Pandemic, depicting an infant, a toddler actually, masking the whole world. How's that been working out? Let us know in the comments how you think it's been working out. Anyway, there are all the different products that you can get. Can I recommend the chiffon top, or one of the ones that includes the full-size graphic? Lots of different options out there to get yourself a souvenir, and congratulations on surviving a global pandemic so far. Let us know how you've been coping. What's changed with you? Let us know in the comments. What's changed since 2019? We're interested to know, and we do read all comments. Thanks to everybody who's left them. Again, check out the merch shop links below the video and on the homepage to the Smasho merch. And let's blast through the volcanic data here. Abico, now we're back on the list here, producing a 14,000-foot ash plume. Unknown ash cloud from Subanose Jima. Fuego in Guatemala exploding to 15,000 feet. Nevado del Ruiz, 22,000 feet as it explodes in Colombia, flight level 220. Sangay and Revenador both exploding in Ecuador, 22,000 foot ash plume from Sangay, 16,000 foot ash plume from Revenador. Sabancaya exploding in Peru, 22,000 foot ash plume, flight level 220, Nevados del Ruiz, exploding in central Chile. Don't pole vault the caldera. It's producing a 12,000 foot plume of volcanic ash. Although if you can do a 12,000 foot pole vault, perhaps you belong in Marvel Comics. Do you have more issues than Marvel Comics? Let us know in the comments. Next, looking at global seismicity. No major quakes over the past 24 hours. There is your 90-day bar graph. And let's scroll up the list here. We've got at least one 5 magnitude quake there at Timor-Leste. There's the location of that one on the map there, north of Australia. That was a 5.0. I think there was one larger quake here. There was a 3.5 in Oklahoma, though. Anyway, let us know if you felt any earthquakes over the past 24 hours. Again, we're always interested in viewer comments. Here's another 5.0. It happened near Kurilsk, east of Russia there, south of the Kamchatka Peninsula, northeast of Japan. Very calm there in terms of earthquakes over the past 24 hours. Getting back to space, this is the imagery we started out on, just zoomed out. It's 304 plus 93 angstroms from SDO. You can see some movement happening there. That's the SDO moving around, not the sun moving around. Although the sun is moving at very high speeds as it orbits the galactic core. So switching to a different set of wavelengths here. Here's 171 plus 335. It's all part of the UV spectrum. And thanks for leaving a comment. Tinman1057, good morning to you as well. Again, I said we're going to spend quite a bit of time here on solar imagery. Check it out. We did have an M-class flare that happened at about 0 dark 20. We'll get to it here momentarily and show additional footage of that. We have seen a decrease in the sunspot number and the 10.7 centimeter radio flux in the past 24 hours as those sunspots are setting in the northwest. 10.7 centimeter radio flux now down to 141 solar flux units, so now it's way down here. That one-year chart there from solon.info depicts the radio flux in black. It's this black line here, and it depicts the sunspot number in red. Expect lots more of exciting activity during solar cycle 25. It's barely gotten started. We've still got a couple years until solar max. So here's a space weather enthusiast dashboard, expecting nothing but calm conditions. I would tend to agree, however, the likelihood of solar flares remains very, very high, as well as the likelihood of coronal mass ejections. So we'll be covering it daily on the channel. Let's take a look at Earth's magnetic moment from space. We've got a very diffuse and very slow solar wind, which means we've got a very low magnetohydrodynamic pressure around the planet. That's the last 4 hours of Earth's rather pathetic-looking moment from space. Earth's magnetic moment there, looking pretty low pressure. And nanopascals are magnetohydrodynamic pressure. Let's take a look at Earth's magnetic moment from the ground. This is the last 4 hours of geospace delta B. The scale here, nanotesla magnetic flux density. This will show you the most likely places for aurorae, pipeline, rail line, and power line induction. When we do see things like geomagnetic storm conditions and geomagnetic unrest conditions, at the moment, no such thing is brewing. We do see some magnetic pulses there over the Far East and places like the Indian Ocean. Continuing on, the planetary K index here, just over 1. KP index 1.33. I like the decimalized KP index better than the basic bars. Give us a little bit more information there, a little bit higher resolution about what's going on with Earth's geomagnetism. KP index, the planetary K index, is a measurement of global geomagnetism. So here's a real-time solar wind, again, very slow and very dense. I mean, very diffuse. So less than 1 proton per cubic centimeter there, and barely 300 kilometers per second. So solar wind here looking very weak. If we do see any signals, like from a CME strike, we can expect a significant signal. At the moment, quite low and quite slow. Here are the GOES magnetometers for the past 3 days. Nothing too exciting happening there. Let's take a look at the heliospheric current sheet since it forecasted sunspot evolution. So if you're able to read this, if you understand what this means, it might allow you to forecast sunspot evolution the way I did a couple of days ago. And I could tell because of the behavior of the heliospheric current sheet to our east. So basically what happened here is I was expecting the North Pole current sheet to show up, and then it got delayed, which told me the likelihood of the sunspots in the southern hemisphere degrading was very high. Without getting too much into that explanation, let's continue on. That's the top view ecliptic plane field plot. I would also note that the north solar polar field here continuing to shrink here. In other words, we are watching the continued progression of solar cycle 25. It hasn't left the heliographic North Pole yet, which means we've got a long way to go to solar max. Here is our line of sight field plot. It shows the solar magnetogram, the sun's B field in blue, solar polar fields in red for south, green for north. And that's our cue to move to coronal holes. So we've got some South Pole and North Pole coronal holes showing up here. The North Pole ones are in the southern hemisphere and are not particularly well defined, as you'll see here in the 211 angstroms SDO imagery. There are some coronal holes down here. Interestingly, they are North Pole oriented. So these are South Pole oriented, these are North Pole oriented. That's the solar polar field reversal process happening. And it's time to move to sunspots. And if you're scared of those, I don't know why, people for some reason are scared of low solar activity. People are scared of high solar activity. The sun is either going to kill you by shutting down or the sun is going to kill you by ramping up. I'm not sure which it is. The fact is that the sun isn't going to kill you, period. So stop freaking out about it, please. It's pathetic. So here's a sunspot situation. These sunspot groups over here need names, especially this one. It's beta class, beta gamma class, which does not make it scary. It does increase the likelihood of it producing flares, but the most likely place to continue to see large flares, including a possible X-class flare. You can see the likelihood there going all the way up to 55% for an X-class flare because of this group here setting 3112. So here is the SDO magnetogram. That's the past 24 hours. Things have largely been stable here, as you'll see in the SDO continuum. And here is that. Not a whole lot of sunspot evolution going on in the past 24 hours. There were some significant flares, though. And let's take a close-up look here at the flare-producing region. That's sunspot 3112 and 3116, and I think there might be another named sunspot group or two. Actually, a little bit of growth happening down here, so a new sunspot forming there right as it sets. So that does indeed increase the likelihood of large flares. Don't be surprised to see an X-class flare, folks. It could certainly be a thing. So let's get to flaring. First, relativistic particles. We don't see any. The proton flux flatlined here. And again, we did see at least one significant flare here. It happened at 0 dark 20 this morning. 0 dark 20 was the peak flux there. It was an M1.54. An M1.54 class solar flare. Also, once again, a decent-sized C-class flare happening as we did show prep. So here's some more solar imagery. It's just splentacular. That's 131 angstroms, and let's zoom in for a closer view. A much closer view. There's that M-class flare happening. We'll let that play through a second time, and then we'll switch to 94 angstroms. Here's 94 angstroms. Got to make sure we get some great imagery there of those sunspots before they set. And here's a slightly zoomed out view in the same wavelength. Great stuff from the SDO. Here's a fully zoomed out view in the same wavelength, 94 angstroms. Next, a star chart we encourage you to look up, and this is what's going on above our head, even though it's very cloudy and rainy at the moment here in Lehigh Valley, Pennsylvania. We've got the moon and Mars up there near the galactic plane, which is that blue line. Also Mercury rising ahead of the sun. Here's a solar system forecast. This is where things are now. Keep in mind this is not to scale. And we'll advance this 1 week. There's where things will be in a week. We will have a crescent waning as we approach another new moon. And let's move on to look at some coronagraphs. So here's some coronagraphs. We do have some CME activity happening. I don't see anything earthly directed there. That is yesterday's activity, by the way. It's 93 frames worth. And here is today's activity. Again, likelihood of coronal mass ejections and large solar flares exceedingly high. Let's take a look at some views from Stereo A and from Lagrange Point 1, the Soho-Lasco C3. So here you're going to see that there's this huge prominence. That is that prominence associated with Sunspot 3112 and the other close-by sunspot groups. Huge magnetic fields there, suspending huge bits of plasma. And that could hang out for extended periods of time. It could eject suddenly. It could even collapse back down toward the chromosphere. But no CMEs in the earthly direction. For you new viewers, Earth would be off in this direction from Stereo A's perspective. We are definitely not seeing anything headed our way at the moment. So here's the 24-hour composite. This is SDO 304 angstroms plus the Soho-Lasco C2 and C3. And there are some stealthy CMEs happening there. They look like they're off to the... They're off in non-Earth directed fashions. Yeah. So there could be some minor earthly directed components there, but they're very diffuse. And not even sure if we'll see any signal from any of those in 3 days or so, so it's not even really anything to be concerned with, for sure. And let's take a look at filaments. So we've got a massive number of filaments here. Check it out. Look at these huge filaments around the North Polar region, huge filaments in the southern hemisphere. That's the El Teide, Spain, ground-based solar observatory in hydrogen alpha, 6,562.8 angstroms. Again, likelihood of large flares, including a possible X-class flare and coronal mass ejections, is very, very high. Remember, folks, you don't need solar flares or even sunspots to see coronal mass ejections happen. Next, the GO 16 SUVI. We'll zoom that out to get a full field of view there. What's great about the GO 16 SUVI is that it shows a wide field of view. And so you can see that huge prominence up there in the northwest. As solar plasma defies gravity due to magnetic fields. Here's the SDO 171 angstroms wavelength for the past 24 hours. It's the house favorite, which means it's time. Time to do bonus features. So we do see some internal charging hazards here for satellites, once again over the central Indian Ocean and Oceania and the West Pacific. Those internal charging hazards are caused by high-energy electrons getting inside the circuitry of satellites, although those are minor internal charging hazards, not major ones. Here's the GOES electron flux. The past 3 days have featured a significant electron storm. Looks like it may be subsiding a little bit here as we've dipped out of warning levels here briefly and then gone right back in with both the GOES 16 and GOES 17 measurements. The GOES 16 and GOES 17 use radiography to measure the electron flux at the F layer from their much higher geosynchronous orbits. They orbit at like 10,500 miles of altitude, and they're measuring the electron flux at the F layer of the ionosphere, which is about 300 kilometers of altitude. Here is the electron flux forecast model, and expecting a huge dip there in the electron flux. No arguments from me there. That's NOAA's forecast, the green boxes. The yellow diamonds are the observations. So here's the 1-year chart from Solon.info. And let's take a look at the Ionosphere vibrational frequency. It's the bridge between Earth and space. So that's one slice of the atmosphere. The upper layer of the ionosphere, known as the F layer, it's showing megahertz, millions of vibrations per second, and we do see lots of anomalies here, which is why we will show the anomalygram next. So here's the anomalygram. This is anomaly in megahertz from a 30-day median. You're going to see quite a lot of significant high and low frequency anomalies happening here. Some wild shifts in places like the Indian Ocean, the Atlantic Ocean. When you see it suddenly shift from dark blue to dark red, that's a huge shift in the median anomaly there. Let's pause it on the latest image and move on. There's 10:15 universal time ionogram, 10:15 universal time anomalygram. This is a persistent anomaly happening in the Indian Ocean right here. It's kind of weird looking, and it is of the high frequency variety. Continuing on to the total electron content forecast, this will show you the most likely places for GPS error, since your satellite providing your GPS signal must communicate through the inner Van Allen belt especially, but also the plasmasphere, a portion of the outer Van Allen belt also, but the plasmasphere, the inner Van Allen belt, the lower plasmasphere, and then the ionosphere, where there's lots of free electrons, there are GPS errors. And we do have some electron anomalies happening here, some electrons quite out of place. This could be an indication that we'll see a huge dip in the electron flux, as we typically see these electrons less organized when we see low levels of electron flux, such as during coronal hole wind streams. We've documented it hundreds of times on the channel. You can see huge GPS errors there expected over large portions of the northern and southern hemispheres. So your GPS could be off by thousands of miles today. Perhaps turn on your Wi-Fi location accuracy. If there are Wi-Fi hotspots, they can help your navigation to be a little bit more accurate. That's your total electron content forecast. Next, showing the sunspots that we talked about, the degradation of. So a couple days ago I said I think these sunspots are going to degrade, and indeed they did. The sunspot in the northern hemisphere grew. That was also a forecast. I said the southern ones will either degrade or the northern ones will grow, or both, and indeed we saw both. That's what happens when you're able to read the data, folks. Maybe it gives us insight into understanding the physics too, but in any case, there are the most likely places to see large flares. Those beta-gamma class sunspot groups in the northwest. They are quite spectacular indeed. And how about some more composite imagery? Here is 304, 211, and 171 angstroms. That's the data from yesterday plus today so far. As it is time to move to meteorology. We throw this in at the end of the video. We used to make everything separate, and frankly, that hurt our views on YouTube. You would think that putting up more shorter videos would increase your views. And of course, if you're a content creator, do not let YouTube gaslight you about what to do with your content. They generally provide idiotic advice, and I don't think they tell the truth to their investors or their content creators or their viewers or their advertisers or their value chain partners or, frankly, anybody. So let's pause for station identification. This is the Smash News Network, least busted name in news, where we cite facts, and we aren't particularly fans of propaganda, fraud, nonsense, corporatism, censorship. Not really a fan of censorship. I think it's pretty pathetic. The answer to bad ideas is more conversations about why the ideas are bad, not silencing the people with the bad and often idiotic ideas. So what we're looking at here next is ocean currents and sea surface temperature. I would note something interesting here. It does look like there is some fresh water here being injected into the North Atlantic. You can see this cold water here being kind of sent down to the south. That is something that you can expect to see as a result of snowmelt. After all, it's the beginning of autumn, so hence the end of summer. We do see some currents there moving down toward the Gulf Stream, perhaps disrupting it a little bit. However, the Gulf Stream still making it to Europe. So Europe certainly did not experience a year without a summer this year. So just putting some facts out there, folks. That is the situation with the ocean currents in the North Atlantic. You can see they're continuing up here to Ireland, and Europe is certainly not freezing. The water still remaining warm there. Although, again, there is some cold water pushing down here. So those are the sea surface temperatures and ocean currents. One of the many series of facts that we show on the channel regularly. Facts. We like those. We don't like propaganda and nonsense. And we don't like channels who put up papers, scientific papers, as proof of their idiotic theories without reading the papers, often putting up papers that refute their idiotic theories. So here are the surface winds of the eastern world. Strong low pressure there in between the Philippines and the Asian continent. Also a strong low pressure here out in the outer Aleutian Islands. Low pressure south of Australia breaking up a little bit. Some strong onshore winds there at Tasmania. Here are the jet streams of the east. Jet streams of the west, also known as the Americas. Huge jet stream kink here pushing some cold air down into the eastern U.S. Definitely some central Canadian cold air rolling through. A high pressure system off the coast of, I'll say, Oregon. You can see an anticyclone there in the jet stream signal. Clockwise rotation. Here is the surface wind scenario of the Western world. Strong low pressure south of Iceland and also in the southern Gulf. Surface winds of the central world look like this. Jet streams of the central world look like this. And let's take a look at some data here. So I just wanted to show sea ice thickness and volume because, folks, it's not just sea ice extent that matters. It's also the thickness. In other words, we want to know what the volume of the ice is, not just the extent. That's a two-dimensional thing. So if you look at the latest graph, that's the latest map, there is indeed still ice at the poles because guess what? You're living in an ice age. An ice age is defined as a time period when there is ice all year round at both poles. So if you look at the ice volume here, it's actually kind of on the low side as the 2004 to 2013 median is this dark gray line. And but it is higher ice volume there than 2019 and 2020. So last year there was a little high, so we got a little less ice than last year, and so on. It doesn't look like an emergency to me, but whatever. If you want to be alarmed about it, feel free. Remember, folks, an ice age is when the planet has ice at both poles all year round. Let's take a look at some more data here. I just want to look at the snow water equivalent. You can see we are well above the standard deviation for snow water equivalent in the northern hemisphere. The snow extent, right inside the plus or minus 1 standard deviation range for snow extent for the northern hemisphere. And it looks like snow mass balance is on the high side, well over 1 standard deviation above normal, as we've seen for the past 6 winters consecutively. We'll show a little bit more data about snow a little bit later in the video. First, clouds and fog. It's 3.9 nanometer radiation, part of the infrared spectrum over the Americas. That's what's going on. And here's your weather.gov map. Some flooding forecast there for New Hampshire and Maine. Also some hard freeze warnings there in southern Colorado. If your county's lit, click your county at weather.gov. We can't go over all of that information, so let's continue on. By the way, Tropical Tidbits is what we typically use to show our GFS models. So check out Tropical Tidbits. That's the home page. And here is I just figured I'd bring up the wind forecast here as we see this tropical system moving back to the south, apparently. That's a GFS 72-hour wind and pressure forecast. And it's going to be windy over the Great Lakes here in the coming days. Some extreme winds there on Lake Huron, Lake Ontario, Lake Erie, Lake Michigan, and some heavy winds in the north-central part of the country as well. That's part of what's causing those red flag warnings. It's your 72-hour GFS wind and pressure forecast. Here's your GFS 72-hour pressure and precipitation forecast. Again, some heavy rains there expected for northern New England. Also some snow falling in places like Minnesota, northern Wisconsin. Significant snowfall expected there in those areas. Also some in Wyoming, looks like it's coming. Once again, that's a 72-hour GFS pressure and precipitation forecast. And let's move to windy.com because I know some people are very frightened that Greenland is melting. Let's take a look since summer just ended. Let's see, how much snow do we have here? Only more than 5 meters. Oh my God, is Greenland melting? Oh, look at this area right here, folks. Look at this area right here. Dear God. There's only a dusting of snow there, folks. Only a dusting. Oh my God. There's 0 snow right there, folks. Stop the presses! Greenland is melting. Although, what's going on the southernmost tip? The southernmost tip, folks. Just the tip. It's... Oh my God. Look at that. There's like no snow there. Oh, noes. Of course, right here, there's 133.7 inches. Anyway, that's your snow depth from windy.com. And check it out. We've got snow in the Rockies. And some snow in Minnesota already. And it's only October 13th. Let's continue on. As we had some significant lightning here in the southeastern U.S. Check it out. Huge band of lightning there, making its way across Arkansas, Louisiana, Mississippi, Alabama, Georgia, Tennessee, South Carolina, and into Florida. Yowzers, some heavy lightning happening there. And do we have any happening now? Let's find out on our real-time lightning map, courtesy of blitzachtung.org, lightningmaps.org. Some different views available there at lightningmaps.org if you like. And we've got some terrestrial strikes here around places like Lake Charles and Beaumont. There's thunder rolling in. Those are some swampy areas right there. Yowzers. It's a pretty heavy thunderstorm happening down there. Also some Some lightning here south of Nolens. That is an estuarial swamp of epic proportions. The Mississippi Delta, folks. Shout out to the Mississippi Delta. It is, shall we say, a large sandbar. Some lightning over the Mediterranean as well. Continuing on to our U.S. Doppler radar map, there is the full 50-state view showing the entire ALSA, the allegedly United States of America, former nation now banana republic. There is the U.S. Doppler radar map. Heavy storms that are moving across Georgia into South Carolina as we stream. Here is shortwave radiation showing clouds and fog. Again, it's 3.9 nanometer radiation infrared satellite. And there is water vapor. You can see that dry mass of air causing some compression. Huge gradients happening there in those areas. See the interaction happening there between that dry air and that less massive moist air. And here's your recap before we close out the video. The U.S. lower 48 Doppler radar map. It's snowing in portions of the U.S. Here is clouds and fog. And if your Doppler radar map has not given you enough information, break out the water vapor map. It'll help clarify things, especially if you understand atmospheric physics. We hope you understand atmospheric physics here on the channel, and perhaps even astrophysics. Thanks for tuning in. Congratulations once again on realizing the channel exists. Thanks for leaving a comment, one audio. We'll see you soon to the Smash News Network, least busted name in news, and may that solar wind be at your back.